Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 2.1, day 2, entitled, What is a Function? And today we're going to focus more on domain of a function and the different ways that we can represent a function. The domain of a function is the set of all the input values that we put into the function. And sometimes the domain of a function is stated explicitly. So for example, they give you this function f of x equals x squared, and then they tell you that its domain is everything from 0 to 5. So it has a restriction on the type of values that you can substitute in for the x. Sometimes, though, we don't have those restrictions, and we have to kind of state what the domain is, or what the general domain is for the whole function. And if the function is given by an algebraic expression and the domain is not stated explicitly, then by convention, the domain of the function is the domain of the algebraic expression. So if you're just given a function, f of x equals 1 over x minus 4, for example, and you're not given any restriction on the domain, then the domain for this function is going to be the domain of whatever 1 over x minus 4 is. Okay, so in other words, the set of all real numbers for which the expression is defined is going to be your domain. So for this function, the value that we could not have in our domain is 4. So the domain would be every number, every x value, except for 4. And for this other function, g of x equals the square root of x, its domain would be everything greater than or equal to 0, because you can't have a square root of a negative number. So let's take a look at these three functions, and let's figure out the domain then, since it's not already stated. It says find the domain of each function. So for part A, we have f of x equals 1 over x squared minus x. Now what I want to do first is I want to take a look at this denominator and I want to factor it. So I'm going to rewrite this as 1 over x times x minus 1. I'm going to factor it by taking out a GCF. So that is just a different way to represent the function. And it'll help me find the values that cannot be substituted in for x. So I'd want to take each little part and set it equal to 0. I'd have x equals 0, and then x equals 1. If I took the x minus 1 and set it equal to 0 and solved it, I would get x equals 1. And actually, those are going to be the values that our domain cannot be. Because if x is 0, that'll make my whole denominator 0. Or if x is 1, that'll make my whole denominator 0. And I can't divide 1 by 0. So my domain is going to be all of the x's such that x is not equal to 0 and x is not equal to 1. So you can write it in the set notation like that. You could write it in interval notation, but it's a little more complicated because you have to say that it's all numbers except for 0 and 1. So if you think of it kind of like on a number line, we'd want to start on our left and come up to the right. So I'd be going from negative infinity all the way up to 0, but I wouldn't be including 0. And I would also want to have an interval from 0 to 1, but not include 0 to 1, but I have to have all the numbers between them. And then I'd also have to have everything from 1 on to positive infinity. So that would be how you would have to include your set notation. Okay, for part B, draw the line here. And let me switch colors. For part B, we have the function that says g of x now instead of f of x. is the square root of 9 minus x squared. So since we have that radical in this function, that's the value that we have to keep positive. So I'm going to start by taking the 9 minus x squared and setting it greater than or equal to 0. That'll keep it positive if it's greater than or equal to 0. Then I'm going to solve. So I'm going to move the 9 over to the other side, divide by a -1, and remember that's going to flip my inequality sign around. And then I'm going to take the square root. Okay, so since my inequality sign now is a less than, that means it's an and. So my domain would be everything from -3 to +3, be everything between them. And if you needed to plot those values on a number line, you could, and you could test what region you're shading. But if you remember those values for your inequality sign, the less than means and, so we want a compound inequality that looks kind of like a sandwich where we're shading in between. And you could write this in interval notation as well. We'd want everything from -3 to 3. And we'd want brackets this time since we have that equality. And in part C then, to find our domain, we have the function h of t equals t over the square root of t plus 1. So I really need to focus on that denominator. The t in the numerator I'm not worried about so much. We can have pretty much any number in there, but my denominator has to stay greater than 0, greater than or equal to 0. So I'm going to take the t plus 1 and set it greater than or equal to 0 again, just like we did in part B. And then when I solve this, I'll have t is greater than or equal to 1. Okay, so my domain is going to be all of the t's such that, now technically, if I put -1 into this function in the denominator, if I put -1 in there for t, I'd have -1 plus 1, which would be 0, and the square root of 0 would be 0, and I would have 0 in my denominator. So really, I want all of the values for t that are greater than -1. And that I just have to be aware of. In my other problem, I didn't have the radical in the denominator in part B, but in part C now, since that radical is in the denominator, we got to make sure that when we find that value that makes our radical positive, that it doesn't make it exactly equal to 0. We can't divide by 0. And we could also write this in set notation. We'd be going from -1 to positive infinity. So you will see problems like that on your homework, and you'll also see some problems like this, where they're going to talk about the 4 ways that you can represent a function. And this is something that we're going to be doing all year. So we've already talked about how we can draw pictures that look like a machine or look like little bubbles with arrows. But really, there's 4 ways to represent a function. You can represent it verbally, which is where you write something out in words. You can represent it algebraically. That's where you have an equation or a formula. You could represent it visually with a graph, or you could represent it numerically. And that is the table of values that get you your graph. And usually that's the one that students tend to skip over. So make sure that if you're representing your function with a graph that you also write down that numerical table of values as well. And this slide shows a chart that's in your book as well, and it just kind of summarizes the 4 ways to represent the same actual function. So they have a box where they're describing the function in words for changing Celsius to Fahrenheit. Then they have a formula. It's a different formula. They have an area formula. They have a graph This is a very compact graph of an earthquake, but it would definitely represent the function. And then we have a chart here that represents the numerical costs of mailing. So this is 4 different examples for 4 different functions, but there are functions where you could have all of these representations for the same function. And that's basically what this says. A single function may be represented in all 4 ways, and often it's useful to go from one representation to another to help us gain insight into the function. However, certain functions are described more naturally by one method than the other. So sometimes it might be better to look at a graph of an earthquake than a table. All right, so example 7 here. This is our last example, and this is talking about how you can use one function and represent it in multiple ways. So it says to find the Fahrenheit equivalent of a Celsius temperature, multiply the Celsius temperature by 9/5 and then add 32. So let F of C be the Fahrenheit temperature corresponding to the Celsius temperature. So we're going to say that F is the function that converts Celsius to Fahrenheit. And they want us to represent that function algebraically, numerically, and visually. So algebraically, we would take that first sentence in this slide, in that little paragraph, and we would actually write out our formula. And that's actually on this slide. So you have to take the Celsius temperature and multiply it by 9/5 and then add 32. And instead of setting it equal to y, like a y equals mx plus b format, or setting it equal to just f, since it's a function now, we have to set it equal to f of c. And notice that c then is the variable in our equation. So then anytime I'm given a Celsius temperature, I can substitute it in here, and then I'll get my Fahrenheit temperature for that Celsius temperature when I actually work out the function. And then part B on the slide wanted us, on the previous slide, wanted us to represent this information numerically. So that's using our table of values. So there again is that table of values. And if you needed to get this information, I would go to your graphing calculator and I would type in y equals 9/5 x plus 32. You'd have to put the 9/5 in parentheses in your calculator, and then you could go to the table of values. Here they're just showing every 10 degrees, and you could adjust your calculator to have that setting as well. And then we've got the Fahrenheit equivalents here. Now it doesn't tell us how many values we need in our table. I'd say at least 3 to 5 probably. Here they just show 6. But again, this is just another visual way to represent this same function. And the last part, part C, was to visually represent this function. So that means we're going to take this table of values and we're going to graph that data. So if we had 0 degrees, that would get us to 32 degrees. And then they have plotted their 6 points that they had in their table of values. You wouldn't necessarily have to put the negative values in there. They did, since obviously there are negative temperatures. So that's a good thing to have. So again, when you're making your graph, just remember to take a moment and think about what this is and what it's representing. Okay, and they've labeled their degrees Celsius and their degrees Fahrenheit. Okay, and they've titled it Celsius and Fahrenheit. But since we do have negative temperatures, you could put those negative values on the graph as well. So don't just restrict yourself to that first quadrant. Think about what the information is that you're graphing and how it can best be represented on the graph. So we didn't have to do too much actual work for that example, but in your homework you will have some problems where they want you to do all 4 representations of a function, or 3 or 2. So there's your practice problems that you can work on. And if you have any questions, come on by and see me before school.